Okay, let's take what we've learned so far and combine it into one example that we're looking at here. First, we want to take our function and we're going to graph it. That's what it asks me to do first. So I have the function ln of x plus 4. So this is the log function that I want to graph. We want to first determine what a is. A is equal to, what's my base of my function? If it's ln, then this is a base e, because that's a log base e is equal to the ln. So a is equal to e, which is 2.7. That's obviously greater than 1 then, and I know this is an increasing function. I also know that I have an x asymptote, or a vertical asymptote, at x is equal to 0, and I know I cross the x-axis at 1, 0. Now, the x plus 4 has the effect of a horizontal shift, because we are adding inside of the function. We have a horizontal shift to the left this time by 4. So I'm going to sketch that over here kind of quickly. So let's mark some things off. 4, 5, 1, 2, 3, 1, 2, that's probably enough. I'm going to start with my horizontal asymptote. Remember, it started here at x is equal to 0, but I'm shifting it to the left by 4. So that's going to take it over here, and I now have a horizontal asymptote at x is equal to negative 4. I know that I have an increasing function, okay, and I know that I normally crossed at 1, 0, which was, I don't know, right there, and we're going to move to the left 4, so that's 1, 2, 3, 4. Now I'm crossing the x-axis here at negative 3, 0. So if I'm an increasing function, I'm going to move along like that, and that's about all I need to know at this point. I graphed the function. The next thing in this problem asks me, find the domain and the range of my function. Okay, so the domain and the range. Remember that the domain of my function had to do with the argument. So where is my argument greater than 0? So that says x plus 4 greater than 0. X has to be greater than negative 4. So the domain of my function would be from negative 4 to infinity, and the range of my function would be from, those are all the possible y values, and we said earlier when we talked about the characteristic of my log functions that the range was from negative to positive infinity. So there's the domain and the range of my function f. The next thing that's being asked of me is, can you now tell me what the inverse function is? Remember that a log and exponential function are inverses of each other. So by finding the inverse of the function we started with, which was a log function, when I find the inverse of it, I should be looking for some sort of exponential function. So let's write that f, my original function, is equal to the natural log of x plus 4. That's what we started with. And I want to find the inverse function of this. So we're going to rewrite this as y equals ln of x plus 4. And when we algebraically find the inverse of a function, we basically come in and we switch the x's and the y's. So here I have my original function, and I'm going to switch the position of my x's and my y's. So this now looks like x is equal to the natural log of y plus 4. I now want to solve for y. So here I want to solve for y. And I have a problem because y is inside the argument. Okay, it's inside of this set of parentheses. In order for me to get it out of the argument position, or out of the argument position, I'm going to use the definition of logs, and I'm going to rewrite this whole expression in its exponential form. So how did we do that a long time ago, many videos ago? We started with the base. What's the base that I have here? It's e raised to the exponent equal to the argument y plus 4. That move right there took the variable that I'm interested in, y, and it got it out of this inside internal position of an argument, and it just left it out here clear and free for me to now be able to isolate it by itself. So if I'm trying to get y by itself, I'm just going to subtract 4 to the right hand side, and I get e to the x minus 4 is equal to y. And I can rewrite this now to look in its inverse function as the inverse function of x is equal to e to the x minus 4. And there I found the inverse of my original function. So here we started with a log, and now I have an exponent, and there we go. Okay, now what is the domain then of my new inverse function? Well, remember when we started this that we said that the domain of one is the range of the other? So the domain of my function is the range of the inverse. So if we come back up here and we take a look at this, this is the domain of my original function. So it is going to be the range of my inverse and vice versa. So the inverse function is what we're looking at. The domain of my inverse is the range of my function, which was negative to positive infinity. And the range of my inverse is the domain of my original. And you can scroll back up to see that if you want. Now that I know the function as well as its domain, the last thing I want to do is I want to graph this new function, my inverse function. So let's rewrite it down here. This was f inverse of x. Let's rewrite that. F inverse of x is equal to e to the x minus 4. Okay, so this is just an exponential function that we now want to graph. I know I start by talking about the base a. A is equal to e, which we already said is 2.7, which is greater than 1, so it's an increasing function. I know that on exponential functions, I have a horizontal asymptote at y is equal to 0, and I cross the y-axis at 0, 1. Now what does minus 4 do for me? Minus 4 is being subtracted from the outside of the function. So that means I have a vertical shift down by 4. So that is what I'm now going to graph over here. And so since I'm shifting down by 4, let's go to 5. We'll go up to 2, and we'll put 2 there. Okay, so I originally had a horizontal asymptote at y is equal to 0 that I am now shifting down by 4. So this looks like, here is my new horizontal asymptote at y is equal to negative 4. And I was crossing the y-axis at 0, 1, but I shifted that down by 4, so I'm crossing the y-axis now at 0, negative 3. This is an increasing function, and so it would just look something like that. And that's the graph of my inverse function that we started out with. So I can go and ask a series of questions rather easily, I would say, if I start with one function, work all the way through, come up with the inverse function, and then talk about domains and ranges and graphs, and I have basically covered both of these sections that we're working on together. Pretty cool.